All right, this is going to be the second video for Notes 34, and we're going to deal with some squares, some circles, and then we'll talk about problem number 4. All right, so problem number 2. I've given you a square, and I've told you that the perimeter of the square is 24 inches. So I'm going to take that perimeter, I'm going to chop it up in 4 pieces, and I'm going to know that's 6, 6, 6, and 6. Okay, what that also means, and immediately I'm going to fill this in, that the radius of the circle is 3 inches. Okay, so if I'm talking about finding the area of the shaded region, I need to do the area of the square minus the area of the circle. That is a horrible little circle symbol. There we go, circle symbol. So area of the square would be 6 by 6. Area of the circle is going to be pi r, which is my 3, right? 3 squared. So that's going to be 6 times 6 is 36 minus 3 squared is 9 pi. My units are inches squared. Right in N. There we go. All right. So 36 minus 9 pi. Units are inches squared. And that is the area of the shaded region. All right. So problem number 2, all done. Problem number 3. The area of the circle is 49 pi inches squared. So area is pi r squared. So 49 pi equals pi r squared, right? Pi and pi cancel out. So r squared equals 49, which means r is equal to 7. So that means I have a radius here of 7. If I double that up, that's going to give me sides here of 14, 14, and 14. Okay, and so I'm going to do the same exact thing that I just did in the last problem. I want the area of the square, which is going to be 14 times 14, minus the area of the circle. So pi, actually, this one I don't even have to write out. Give me a second, I just realized that. Because in the problem, I outright told you, I'm trying to grab a highlighter, the area of the circle is 49 pi. So I'm just going to write down 49 pi. Let's see, 14 times 14 is 196 minus 49 pi. And as far as units go, that is going to be inches squared. All right. Last but certainly not least is problem number 4. We've got a soccer field. Soccer field is a rectangle. So I'm going to go ahead and draw a rectangle. I'm not going to worry about it being too... Wow, that's horrible. We'll deal. Let's go 9 meters wide, 120 meters long. The coach asks the players to run from one corner to the corner diagonally across the field. So what that means is we're doing a diagonal. So corner here, diagonal to corner here, that's the running. Okay, and it is a rectangle, so there's a right angle here. Okay, and we've got, let's see, leg, and then the third side is the hypotenuse. So Pythagorean Theorem says we are going to do leg squared plus leg squared equals hypotenuse squared. I did mark this one with a little asterisk because this is absolutely going in my calculator. So let me see if I can pop the calculator up here. Whoops. There we go. Okay, because 90 squared, 90 times 90 is 8,100 plus 120 squared, that's 14,400 equals x squared. So if I take 14,400 plus 8,100, that is 22,500 equals x squared. On the off chance that I can take a square root here, I'm going to quickly transition this. I'm going to grab scientific. Yep, there we go. And I want to take the square root of that last answer. Love that. Oh, that is perfect. Nice. So x is equal to 150. Now, for this particular problem, let me lose the calculator here. I do not need to worry that when I took the square root here, and I will actually mark that, right? Square roots, you know what happened. There should normally be in a problem like this, when we're solving for a square root like this, a plus minus. However, I do not know how to measure a soccer field or any measurement for that matter as a negative 150. So that would not make any sense. So how far did the players run? 150 meters. And that is the final answer there. So that should be it for notes 34. This was the second part. As always, if you have any questions or concerns, please let me know. Oops. Turn the video off, not grab the calculator back. There we go.